Okay, kids, we're going to be doing mole class number 2. We're going to be calculating molar mass, counting atoms in any mass of a compound. I have my calculator. Of course, I have my periodic table. You cannot do this class without either of those things, so go get them now. Hit pause and go get them. Welcome back. Here we go. First of all, what's the name of this compound? We're going to write the name down. You should be able to do that. We've already taken the celebration on this. MnO4 is on table E. That's aluminum, of course. How do we calculate the mass of 1 mole of this stuff? Now, the only way to do that is to write the formula, Al parentheses MnO4 3 times. And then underneath, we're going to list all of the parts to this compound. It's got aluminum, it's got manganese, and it's got oxygen. Now, there's a big gray box here. Only work on half of the page. This process that we're going to do now, what is the molar mass? We need to do it on half the page because next to it, we need that space for something you don't know what it is yet. We're going to another calculation that comes after molar mass. We're at the beginning stage. We're going to do molar mass. It's a good thing to know, but we can also use that to figure something else out. So we're only going to get used to doing it on half the page. Save that other half, okay? That's why there's a gray box. The name of this stuff, of course, is aluminum permanganate. And this is how we do it. In this formula, there's a single aluminum in the formula, Al. We don't write the number 1. Al1, and on the periodic table, if you put your finger in box number 13, aluminum has an average weighted atomic mass of 27 AMU, so there's going to be 27 grams. And then we would multiply across. 1 times 27 grams equals, what's it equal? 27 grams. Write that down. Now, MnO4 is in parentheses and it's tripled. So you got to be careful because how many manganese do we have in this compound? And of course, it's 3. Manganese is element 25. So if you put your finger in a box 25, the mass of manganese rounds to 55 grams per mole. So it's going to be 3 of them times 55. And then you multiply that across and look what you get, 165 grams. So part's aluminum, part is manganese, and now we got to do the oxygen part. O4 in permanganate, but it's tripled. 4 times 3, we got permanganate, permanganate, permanganate. It's a triple permanganate. So we're going to have 12. And each oxygen is 16 grams per mole. Now, this is a little tricky, of course, for some of you at the beginning. Oxygen, when it's pure, is O2. But oxygen in a compound, you could have 1 oxygen or 2 oxygens or 3 oxygens or 12 oxygens. In this formula, there are 12 O's. Each O is 16 AMUs for an atom or 16 grams per mole. Oxygen pure is O2, and that's 32 grams per mole. But here, there's 12 times 16. You write this all across, and then you have to add them up. So the sum total is called the molar mass. If I said, oh my gosh, I gotta have a mole of aluminum permanganate, you can't count to 6.02 times 10 to the 23rd formula units. It would take you 45,000 years. Really, I'm not even kidding. It's that big a number. You figure out the molar mass, you shake it on the scale. This is, 454 grams is a pound. This is like 3/4 of a pound. This is like a Big Mac and a half. It's a chunk. Aluminum permanganate, the molar mass. 1 mole of aluminum permanganate is 384 grams of aluminum permanganate. That's what the molar mass is. Now, I like this cartoon. Look at the cartoon first. This is like, oh, my life stinks. What are we going to do? How are we ever fooled by such stupidity? New York State hates teenagers. This is an important slide because if you don't pay attention, you're probably going to lose 1 point on the Regents exam. Because New York State, for no good reason, likes to use these 2 extra vocabulary words. Instead of just saying molar mass all the time, there's other ways to say it. Now, if you have a molecular compound like carbon dioxide that has no metals in it, or water, or octane, gasoline, if you have a molecular compound, you could have a molar mass of a molecular compound, or you could have what's called the gram molecular mass. The gram, how many grams would be the molar mass of a molecular compound. Or if you have an ionic compound, you You can have, we just did it. Aluminum permanganate, it's an ionic compound. We have a molar mass. We could also call that, though, the gram formula mass because they come in, instead of molecules, they come in formula units. Both of these stupid vocabulary words. This is stupid, but they hate you, and I don't. These are just two different ways to say molar mass. You can always say molar mass. What you have to realize is when you read this silly stuff, if it's on the regions, and I'm going to put it on your celebration too, I promise, because you got to know it. It means molar mass. Don't be fooled. See the guy in the green? Oh, how did I get fooled? I'm wearing green today too. It's not even St. Patrick's Day. It's just green shirt day. All right. Yeah, I'm using it again. Look, I even got it in green. What is the gram molecular mass of this compound? It happens to be something called 1-octanol. You don't have to know that. There's 8 carbons, octo, and it's an alcohol, so it ends in an OH. This is an organic chem molecule. It burns really well, but you can't drink it. This would kill you. But it's a kind of alcohol. What does this question mean? It means, what is the molar mass? It happens to be molecular because there's no ions, there's no metals. It's a molecular compound. So instead of saying, what's the molar mass, I said, what's the gram molecular mass? There's the formula. Draw a line under it, and then we're going to list all of the atoms. Now, something you can see probably right off is that hydrogen's in 2 places. And rather than combining it, let's just do it in 2 places. We'll do 16 on the top, or 16 H's, and then we'll do 1 more H at the end. Don't try to mix things up in your head. Just do what it says. Slow and steady wins the race. So there's carbons, hydrogens, oxygens, and more hydrogens. CHOH. How many carbons? There's 8 carbons, and each carbon, if you put your finger in a box, has a gram molecular mass or a molar mass of 12 each. So there's 8 carbons, there's 16 hydrogens, there's 1 oxygen, and then there's another hydrogen at the end. OH is a special thing we're going to learn about. It's not a hydroxide, like we do have an OH negative ion called hydroxide. This is a molecular compound with OH. This is a different, it's not an ion. It's called an OH group. It makes it an alcohol. So 8 times 12, because the molar mass of carbon is 12 grams per mole. 96 grams of this mole is made up of carbon. And then 16 more grams is made up of hydrogen. Now there's only 1 oxygen. So there's another 16 grams of this compound that's made up of oxygen. Excuse me, a little bit of seltzer. And then there's 1 lone hydrogen on the end that's only 1 gram because it's a single atom. It's not a Hunkelbrief twin because it's in a compound. So you got 96 grams of carbon, 16 grams of hydrogen, 16 grams of oxygen, and another gram of hydrogen. Then you have to add it up. What's the total? Bada bing, bada boom. This stuff is 119 grams per mole. That's the molar mass, the mass of a mole. Or you could say it's the gram molecular mass if you want to be snooty or annoying. This says, what is the gram formula mass? That's the other stupid vocabulary word for an ionic compound. Ionic compound. They come in formula units, not molecules. I didn't give you the formula because I'm expecting you to know how to do this. Sodium, of course, is a positive 1 ion. Sulfate is a table E. Let's look it up, all right? I'm going to model some good behavior. Sulfate, SO4, -2. When you do the whole crisscross, look what we get. Na2SO4. We need 2 sodiums for every sulfate. Now, what do we got in this compound? We got sodium, we got sulfur, and we got oxygen. 3 different kinds of things. How many sodiums? 2. How many sulfurs? 1. How many oxygens? 4. So we have to multiply 2 for sodium times the molar mass of sodium, and 1 sulfur times the molar mass of sulfur, and 4 oxygens times the molar mass of oxygen. Look what we got. 2 moles times 23 is 46 grams. That's the sodium part. And now for sulfur, there's only 1. 1, and sulfur has a molar mass of 32 grams per mole. So it's 1 mole times 32 grams, it's 32. And then finally, we got 4 oxygens here, and that's 64. And now you got to add them up. The part that's sodium plus the part that's sulfur plus the part that's oxygen is the whole. The sum of the parts is the whole, and this stuff is 142 grams per mole. So if you wanted a mole of it, you'd have to put 142 grams on the scale. If you wanted half a mole, you only put 71 grams on the scale. If you needed 2 moles for some reason, oh my goodness, got to have 2 moles of sodium sulfate. That'll be a bad day, right? If you ever had to actually say that, I need 2 moles of sodium sulfate, you would need what? 284 grams. You could figure it out on paper and then just go to the scale. This is easy. Now, let's see this blue problem. You have 4 significant figures here, 183.2 grams of sodium sulfate. How many moles is that? Now, I sent this email to you the other day about doing stuff like this. You have to always do it the same way because it's going to get bigger and bigger, and you got to know how to get to where you're going. So we're going to start with the starting point. We're starting with 183.2 grams of sodium sulfate, and I wrote the formula this time to make it smaller. Put it over 1 because that puts the grams of sodium sulfate in the numerator. Up on top where it says in blue, it's in the numerator. You just don't see it that way because it's written as just a number. Put it in a formula with a fraction like this. Put it to the top. We just figured out the molar mass of this stuff. We have to multiply it by a conversion factor that we get from the molar mass. Now, 1 mole, see what this says right here? Look at this, I made a boo-boo. What does it say nickel for? Na2SO4. Oh my gosh, I'm wrecking it. Who's in charge of writing these slides out? How did that happen? Oh my gosh, I got to make the too little now. All this work I got to jump in and do. Somebody should be doing a better job on these dang slides. Who's wrecking it? Who is wrecking it? I want to know so that I can give that person a little bit of a discount in their pay. 1 mole of sodium sulfate is 142 grams. Look how the grams cancel. The grams in the numerator, that's how you know how to put your conversion factor in. You don't want to put the grams on top and the moles on the bottom because then they won't cancel. The units have to cancel. That's why you put them in the front on top so that you know how to put the conversion factor in. Cancel them out. This becomes fraction times fraction. Multiply across the top, multiply across the bottom, and look what you get. 183 divided by 142, it comes out with 4 significant figures. So we went from grams to moles because they're the same thing. They're just a different way of saying it. There's a mole that's equal to the molar mass. You have this many grams, it's a proportion to the mole. In this case, you have more than a mole. How much more? You have 1.290 moles. Grams can become moles, moles can become grams, no problem. Look at this one. It's your lucky day. 454 grams is a pound. This is more than a pound. You find more than a pound of gold, honest to goodness, it's your lucky day. Gold is pretty expensive, right? You can make a wedding ring out of it. There's not that much gold in my ring, but it stays shiny forever, right? And it's a token of the love and affection that my wife has for me. And I love her. This is worth, whatever you pay for it, it's worth it. It will last forever. And it doesn't rust. That's why they call it a precious metal. It's not precious because it's gold. The fact is, gold is pretty soft. They actually mix some other metal in here, probably some nickel to give it some strength. Gold is too soft to have a perfectly gold, only pure gold ring. But it stays shiny, it doesn't rust, and it's gonna last forever. That's the whole trick, right? You get one of these, you never take it off. All right, 551 grams of gold. How many moles is that? Well, we got to start. Where do we start? We start at the starting point. 551 grams of gold over 1. AU, are you paying attention? AU. AU is the symbol for gold. That's like a joke. AU, are you paying attention? All right. Put your finger in box number 79. What is the molar mass of gold? Because we have to do a conversion. We're going from grams to moles. We got to multiply this by the conversion factor. And it says very clearly in my box that it's 198 grams per mole. 198 grams of gold is 1 mole of gold. So look what we got. I'm sorry, 197. I need new glasses, I'm getting old. It's 196.967, 197 grams per mole. I can't fix this, it's a zoom. I'd have to replace the whole video and I'm not going backwards. Oops, this is correct. Grams in the numerator, Grams in the denominator, they cancel. And now multiply across 551 times 1 divided by 197, and the unit is going to be moles of gold. Make sure your units work. The units will keep you honest. If you put the numbers in the right place, everything cancels, and the only unit left is the unit you want. How many moles of gold? You're going to get the answer. It's going to tell you moles of gold. Look, do the math. 2.80, 3 significant figures. Grams can become moles in one-step conversion. It's not a problem. Not a problem. Okay, now we got 4 significant figures. This is hard, right? Because we got an extra significant figure. 37.33 grams of silicon, element number 14. How many moles is that? Heck do I know? We're going to figure it out, though. We have to start at the starting point. Where are we starting? 37.33 grams of Si over 1. We always put it over 1 so that you realize in your head and your eyes the grams of silicon are in the numerator. That way, when we write the conversion factor, we put the grams of silicon in the denominator and the moles in the numerator. Put your finger in box 14. I'll look a little more careful. 28 grams per mole. I'm pointing. You can't see what I'm pointing at. There's grams in the numerator. That means the conversion factor is going to have grams in the denominator and moles on top. This is a perfect setup. And then look what you do. Boom! You cancel them grams out. The grams divided by grams becomes 1. We cancel, we throw it away. The grams are gone. The only unit that's left is going to be moles, which is exactly what we need. So you have 37.33 times 1 across the top. That's 37.33 over 1 times 28. 28. So you got to do a division problem. Bada bing, bada boom, with 4 significant figures. Now look, the red. There's always unlimited significant figures in the conversion factor because you didn't measure it. It's an equality. We have 4 significant figures in the starting point, have to have 4 in the answer. Now, this is something we did the other day, Avogadro's number. Remember that funny looking guy, the Italian chemist, Amedeo Avogadro? 6.02 times 10 to the 23rd particles equals a mole of them. You could have that many atoms and have a mole of atoms. You could have that many molecules and have a mole of molecules. In this case, we're talking about zinc. So it's going to be that many atoms of zinc equals a mole of zinc. So this is a harder problem, right? Look at these numbers. Oh, look at that big number. It's going to be hard. How many moles of zinc are in this many atoms? We haven't done a problem like this before, but we're going to do it now. It's not that hard. You just got to use a calculator and take your time. What's our starting point? We're starting with 1.25 times 10 to the 23rd atoms of zinc. That's where we're going to start. Now, the conversion factor here, we don't care about grams. We're not talking about grams now. We're going to go from atoms to moles. So what do we know about how many atoms is a mole? I'm going to go backwards. Look, I'm going backwards. What's it say right under remember there? 6.02 times 10 to the 23rd atoms of zinc equals a mole of zinc. That's the equality. That's the conversion factor. So here's our starting point. That's how many atoms we're starting with. We want to figure out how many moles it's going to be. So we have to multiply it by atoms on the bottom and moles on the top. That way the atoms of zinc will cancel numerator denominator, and the unit that's left is going to be moles. And look what happens. Boom! We exit out the atoms of zinc in the numerator with the denominator. They divide to 1. So now we have a big math problem, right? There's no doubt about it. 1.25 times 10 to the 23rd divided by 6.02 times 10 to the 23rd. We're going to break this into little chunks. We're going to do the front part, the coefficients first and divide, and then we're going to do the second part, the exponents and divide. So watch what happens on this next slide. This is a little, make sure you see this. You might have to pause it and really look to say, none of the numbers are going to move, but we're going to move them a little. It's 1.25 divided by 6.02. That's the coefficients that we're going to divide. Then we're going to multiply it all by the numerator exponent divided by the denominator exponent. So we're going to be able to do this in 2 separate chunks, so we could use a little calculator. We don't need a big fancy calculator to type all these numbers in and use the EE button. Forget about it. Just do it on paper. It's really easy. Now to do this, the first thing you really should see is whatever 10 to the 23rd is, if we divide it by itself, that's just going to equal 1. Boom! That equals 1. Anything times 1 is 1. So we're just going to get rid of that part. We don't have to do anything with it at all. What is 1.25? Here, let me help you. 1.25 divided by 6.02, and that, my friends, is going to give you the answer. Look at that. 2.08 moles of zinc. All the exponents did was divide away. They're really big, these numbers, but they also divide really well, too. 3 significant figures in 1.25, 3 significant figures in your answer. All right, I think there's only a couple more questions. Oh, look at these guys. Calvin and Hobbes, my favorite cartoon in the world. I really like them. If you don't know Calvin and Hobbes, look them up on Google and read some of the cartoons. Calvin's a cute little boy. Hobbes, his pet tiger, is really a stuffed animal when adults are around. But when adults are not around, in his imagination, the tiger comes to life, and it's fabulous. So this is a really big number. Look at this one. How many moles of xenon gas are in 8.75 times 10 to the 24th atoms of xenon? Xenon is element number 54. I used to be 54 years old, but now I'm 60 and a few days. Look at this. Where are we starting? We have to go from atoms to moles. We're starting with a whole lot of atoms. Let's put that number over 1 and set it up to start. 8.75 times 10 to the 24th atoms of Xe for xenon over 1, because the numerator is where those units belong. This is a gigantic number. Doesn't matter, though. We're going to divide it by a pretty big number, too. We want to go from atoms to moles. What do you got to remember? 1 mole of any gas, or 1 mole of anything, is equal to 6.02 times 10 to the 23rd atoms of that thing. So that's our conversion factor. We just used it before. We're going to use it again. Now we got atoms in the numerator. We got to set it up with the atoms of xenon in the denominator, and we put the moles in top. That way, when we get in a second, I'm going to cancel them in a second. The atoms in the numerator are going to cancel. Ready? Boom! It's like a karate knife. Get rid of those atoms. So now we just got a gigantic math problem. Now remember how we did it before? We're going to do it again, nice and slow. This big number, 8.75 times 10 to the 24th, divided by 6.02 times 10 to the 23rd. If you have one of those big fancy black calculators and you know how to use it, good for you. I got a toy, but I know how to do the math. So what are we going to do? We're going to divide the coefficients, and then we're going to multiply them by dividing the exponents. I'm going to set it up for you just like this. Look what we got. 8.75 divided by 6.02. You see that? The numerator coefficient divided by the denominator coefficient. Then we multiply, and we have 10 to the 24th divided by 10 to the 23rd. So now we got 2 problems because the exponents are not really going to cancel. 8.75 divided by 6.02. I'll do that right now. 8.75 divided by 6.02, and that equals 1.45. You see that? 1.45. Now, what the heck is 10 to the 24th divided by 10 to the 23rd? I taught you this a long time ago. Dividing exponents like this, you just subtract them. 10 to the 24th divided by 10 to the 23rd is equal to 10. Take away just 10 to the 1. What's 10 to the 1? 10 to the 1 means 10. So you got 1.45 times 10 to the 1, which really means 10. So you have 1.45 times 10. You have 14.5 moles of xenon. Now, I know this doesn't seem like too important to you, but this is amazing. We went from atoms and we switched it into moles. This is a gigantic number of atoms, gigantic. This is 10 times bigger than Avogadro's number. This would take you 57,000 years to count. Not even that many moles, 14 and a half. You're all older than that, I think. Last slide, the day. I'm wearing green, right? It's like a jack-o'-lantern. You find 50.0 grams of pure silver. How many atoms did you find? We're going to go from grams to atoms, and there's no direct connection. In order to do this, we have to take the grams and convert it into moles. And then, once we know how many moles of silver it is, then we can convert it into atoms. So there's 2 steps. We can do this. You could do this, but you have to go through moles. Moles is central to chemistry. And we're ready for this. This is a big problem. This is a 2-step problem. This is no joke. This is going to take more room. Write big. I mean, don't write big. Write small so it all fits. It's going to be a bigger problem. 2 steps. We're going to start at the starting point. What do we got? What are we starting with? Starting with 50 grams of silver. So this is what we do. 50 grams of Ag over 1. And we have to turn it into moles. We go from grams to moles, and then we go from moles to atoms. First step, silver. Put your finger in box 47. It's 108 grams per mole. So how do we set up the conversion factor? We got to multiply it by something equal to 1, a conversion factor. So we're going to multiply it by this. 1 mole of silver over 108 grams, because 108 grams of silver is equal to 1 mole. And watch, the grams are going to cancel. Bada bing, bada boom. And when you do this math problem, right, here it comes, you're going to convert that into moles. Do the math. I'm going to do it. Ready? 50.0 divided by 108 equals 0.4629 something. Rounds to 3 significant figures, 0.463. So, all right, that's good. 0.463 moles. We got an equal sign, but that's not the answer. That many grams equals that many moles. What is the question? Not how many moles, how many atoms? So we're going to move that over to the other side of the page now, and we're going to do the second problem, the second part of this to figure out the answer. So the next step is we just move it over there so we have room. If you had a really big piece of paper, you could keep going, but I don't have a big piece of paper. So I'm going to move it over here. I want to go from moles of silver to atoms. And you know what I remember? 1 mole of anything is equal to 6.02 times 10 to the 23rd atoms of that. So since moles is already in the numerator, I'm going to put moles in the denominator, and I'm going to put the big number on the top. See what I did? This conversion factor in the middle of the page, 6.02 times 10 to the 23rd atoms, divided by a mole, that's equal to 1. But by multiplying it that way, I get to watch. Here it comes. I cut them both. I cancel the moles. The units cancel. And now the only unit that's going to pop out is atoms of silver. And that's what I want. That the units tell me I'm doing it right. The units tell me nothing's upside down. The units tell me, really, unless I press the wrong button, I'm going to get the right answer. When you do these problems, if you use your units, you'll know you're right. I mean, unless you do something really just stupid and you hit a different number by mistake and you don't watch. But if you do this setup and you still get the wrong answer, you get 9 out of 10. The setup, the thinking, what are you doing? That's what's important. Now, how do you do this math problem? You're going to multiply 0.463 times 6.02. So I'm going to do that. 0.463 times 6.02, and that equals 2.7, I don't know, 2.787. That's going to round to 2.79. Oh, look, I got it written down in red. That's what I did, times 10 to the 23rd. So it's going to be 2.79 times the exponent. 3 significant figures, we're done. D-O-N-E done, D-O-N-E done, we did it. I love moles. Moles are central to chemistry, central. We just went from grams, so like put it on a scale. How many atoms are there? Holy cow. We did that because of this concept of moles. There's molar mass, and there's numbers of particles that make up a mole. Moles in the middle of everything in chemistry, and now you are in the middle. I'm stuck in the middle with you. Now there's a good song. There's a band called Steelers Wheel, S-T-E-A-L-E-R-S, Steelers Wheel, stuck in the middle with you. Check that out on YouTube. I'm telling you, that's your homework. Steelers Wheel, stuck in the middle with you. And look, one last slide. If you're really smart, you can check this out. I don't like to do it this way. I like to do it in steps. But if you're really smart, and some of you really are smart, we can start with 50 grams of silver. We can first convert it into moles, and then without putting an equal sign, we can just keep going, and then we can convert moles into atoms, and we do a giant, one giant math problem, and of course we get the same answer. Now, honestly, In other classes, they do it this way. This is a one big dimensional analysis problem. I don't like this because, I mean, I can do this and it's quicker, but at first you don't really know what the heck you're doing. It's better to do simple steps like grams to moles and then moles to atoms. If you do it like this, churn, 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 you can do all kinds of conversions, but you're not really sure what's going on. You just get the right answer. You can look at this slide. I don't like it too much. I do it sometimes, but I like to go in steps. I like to draw pictures. I like to tell jokes. I like to have a shark. Tomorrow we draw the shark. Get excited about that. That'll be fun. Thank you for listening. Thank you for playing. Go outside and breathe some air and look at the sky, all right? It's important to stay alive and to be happy. Bye-bye. And now I'm going to hit end all. End. Goodbye.